Okay, it's about time. Let's start. So, welcome to this quickie. Today, I'm George Oikonomou. I'm a senior engineering manager at eFood, and today we're going to talk about behavior-driven development and of course testing, and why it matters in the software development lifecycle. What advantages does it have, and how we start using it at eFood, and what benefits do we get out of it. So we'll discuss three things. First one is what is BDD, of course, and next is going to be how it can help teams' productivity, and how do you approach it in various languages and technologies and domains. It's going to be a short one, but yeah. So, but before we jump into this, let's see what is the problem, what we are trying to solve. You all write software, hopefully. How many of you write software here? Okay, cool. I hope you also write tests. Yeah, great. Not many hands this time. Right. So we write tests and we try to improve our test coverage. And one of the things that we found that we always have bugs and defects. And that's a normal part of the software development lifecycle. What we found out is that the root cause of these is actually the deep understanding of the requirements of a project or a ticket or a Jira story or whatever the tech team is trying to implement. And this lack of deep understanding is not because people don't pay enough attention. It's natural to happen. And sometimes it's because of the language barriers. If you are working in a multinational company and you've got people from different backgrounds and experiences, it can be that people have different interpretation of the same thing, so they don't share the same common sense approach. And it could be also the domain. Some of you may work in difficult domains. Some of you may have work in a domain that's easy to digest. It depends. So it depends if you write software for an MRA machine versus writing a website. It's the different technologies and expertise and the domain knowledge that's required. So this has so we have some problems, and this causes uncertainty in the teams. It slows down the development, and it causes frustration in the business people and the tech people as well. Is everything right?
Yes. Where's the microphone? The handheld.
Handheld. Just give me a sec.
It's better for you.
Okay. Yeah, I feel like a singer now. Is it better? You want to turn it on? Great. Okay. Is it better now? Thank you. Right. So we said this causes lots of uncertainty, and people get frustrated, and you get slow-pacing teams. And it's not because of the people; it's because of the process. So what is BDD now? It's behavior-driven development. Is an agile software development technique. It extends TDD, test-driven development, and it promotes the collaboration between technical and non-technical people. So this can be the business stakeholders or the product organization or the product managers in a team, the QA team and the technical team, the developers. Okay, so it focuses on the providing clear understanding of the desired behavior of a piece of software. As we said earlier, it extends TDD. Instead of writing unit tests, you write BDD tests. And it uses native language to describe what we are trying to test. We'll see an example later on. And last but not least, it focuses on, it drives people to think about why the solution that they are trying to implement matters, and focuses on the user experience and the user values. What are the practices? How do we practice BDD? First of all, we encourage people to establish the goals between the different stakeholders to have a shared vision and know where the project goes. We involve the stakeholders earlier, so we try to get as many details and as many edge cases as we can early in the process. We use scenarios to describe the behavior rather than unit tests and abstract descriptions and long sentences. We have small steps and scenarios to break down a bigger feature. It's always best to automate the scenarios upfront, so you actually test the system, test fails, and then you satisfy the tests, and then it passes and everything goes green and you can ship it. And by using should and ensure, it helps you clarify the responsibilities of a team and people outside the team and the QA teams and everyone is involved that is involved in the project, and also evaluate the outcomes. Okay, now let's see the core concepts. How many of you have know what Gherkin is here? Great, many hands up, thank you. So you obviously have seen all of these before. Gherkin is the language that we write, mostly we write BDD tests. There are some libraries out there that don't use Gherkin, but that's out of context for this talk. So you get some primary keywords. You all have seen scenarios and the specific given, when, then syntax. And this is how you describe your test steps. We're going to see an example actually in a bit. We also have some other basic keywords like background up here, and examples and scenarios are the same depending on the language, and you've got rules and features. We're gonna see an example and come back in a bit here. So let's see a real life example that we have. So let's say we are eFood. We are a food delivery company. At least we started as a food delivery company. We do more stuff now. And we want to send a notification to the user when the order is next by, and is so to get prepared and receive his order. Our scenario is this. So we say the order is near the user, and given a customer, now is the implementation, and that's the steps. So we say given a customer places an order on eFood, and the order is delivered by an eFood rider, because we also have some marketplace orders. When the rider is less than 5 minutes away from the customer, then the customer receives a push notification saying that the order is arriving soon. So what we have here, we have a scenario, we have the given. So we establish a situation where we have the prerequisites, then we have the when, which is the action that triggers the outcome, and the last step is where we're validating the expected outcome. So as you see here, we have our scenario. It's very easy to digest and understand. Hopefully, non-tech people it's going to be easy to understand. And tech people can take these steps and implement them in an automated way, so they can use them in their tests. As we said, we have some other steps here. Like I'm going to stay here for a sec. We've got background as well. This is where you set up background jobs that are running in before each scenario. You've got scenario outlines, which is pretty important if you want to test with different provided values and different parameters. And you also get features that is basically a group of scenarios assembling the bigger picture. Right, cool. So we've seen the test, we've seen the scenario, we've seen what goes into the documentation and the tickets. Now let's see an example. That's from Python, but we're going to see other languages later on and what support is there. So we'll say we want to implement the first one. We want to implement the given. So customer places an order on eFood. A step implementation like this can look like that one. You first open up the browser and you grab the form from the HTML document, and you get an element, you press something, and then you submit the form. This is the actual code that is going to run when you run your test. And that's pretty awesome, actually, because most of the time this is manual labor work that a QA engineer needs to do in order to validate something. With this one, you do it once and you automate it and you have it forever. So let's spend a couple more minutes here to see what are the actual keywords. The three most important keywords are in order to create a test. You've got the given, and this is the most important step. Is actually when we have given steps, we try to put the state. We try to establish a state in a piece of software. So. In our case before, we had the order, but we don't want to test the order, remember? We want to test what happens when the order is nearby the user. So we create the order and we put the system in a state ready to accept an action, and validate the results. And this is what given does. And we have the when, which is actually the trigger that causes the action. And with the when it can be a click of a button if you've got a UI, it can be an automated work, it can be a Kafka event, maybe, I don't know what you use, or it can be any other external interaction. Remember here, we don't focus on the what happens behind the scenes in the software, we focus on the end-to-end result. So we want to test the outcome. We want, with the then, which is the last word, we want to test what the observation is. Okay, you've got state, you've done an action, and what do you expect? And this is where it comes all to play, which is, it makes people think about what the outcome of the software is instead of thinking about the technical details and the solution. So you get lots of people in the organization to think about all these details up front. You say, okay, I've got an order, what happens now? What do we do now? What do we do in that case? What do we do if there is a, I don't know, a backstack order? What do we do if there is a delay? And all that stuff comes. Okay, so what are the benefits now? Of course, you can automate the tests. PDD, like all the automated tests, there are obviously the benefits are obvious. You get regressions, and you don't replicate yourself, and you don't need as many QA hands to deliver a piece of software and test it. You've got a structured way of thinking, so instead of relying on people's common sense to describe something, you've got a pattern, you've got a template, and it's how you communicate. So people will naturally get better and better in communication by thinking in the same way, kind of. You've got more hands early, and you discover more details early in the process because you don't rely only on product people and business people to provide you with all the cases. It's a contribution from different departments of a company, different teams. You focus on what matters because you test the outcome, and you don't focus on the details. You don't care if it's a Kafka, if it's an SQS, if it's AWS, if it's a streaming call or something. You care about what happens, and that's what where the beauty of the thing is, because you build something for the user. You don't build to satisfy maybe your problem-solving skills and needs, and maybe some other stuff. You focus on providing the best for the user. Here, the user can be a system, but don't take my word for granted. But it's actually the user of the system. It can be in a microservice, can be another microservice, or any other piece of software. One thing that I have seen in my career quite a lot is that specs are not. There's always that common problem between specs and implementation. Technical people don't know all the technical details up front, and they are called when they're actually implementing something to think about the details. And tickets are not written in a way that everyone understands. And I haven't seen in my career actually in a company writing proper user stories. So say, as a user, I want to do X, Y, Z, then blah, blah, blah. And with BDD, it's very, very easy to map. So you get given and say as a given, when I do that, you do that, blah, blah, blah. Of course, you focus on the behavior. You don't focus on the technicalities. You got all the advantages, and that's a very, very important one, especially for you developers. How many of you tend to commit code that is broken? In the development branches, not in the master branches. And so especially for you, it's very beneficial. People tend to, and I want to spend a minute on this one because it's quite important. It's about our work-life balance. So we tend to overwork, and we tend to try to deliver something to leave it in a good state for the next day, because no one wants to come in the morning and say, well, that's broken, where I went. I need to remember all the details and think about what happens and build that test case again and manually test and fix that broken thing. With TDD and BDD, actually, you can leave the system in a broken state and you don't care, because you will come the next day and you will have the failing step. So you can continue up to that point with success, and then build all the cases to satisfy the next steps. That's very beneficial for you. It's very healthy. Of course, you use natural language, as you have seen, and that's very easy to communicate the requirements. But you can get the live documentation as you build the code. It's embedded in the tickets, and it's a common language across. And that helps you make better decisions, both you developers and non-tech people as well. So yeah. And the last one, because we don't have too much time, unfortunately, there is support for most of the major programming languages. On eFood we use Python, Go, we use JavaScript as well. I know many of you use Java, because I've heard Java quite a lot of times these couple of days. So Java is already supported by Cucumber, Python has Behave, Go has Gecko, and all major programming languages, some have some kind of support for Gherkin and test implementations. There are many test reporting tools, not only the command line, where you can automate it and build it into your CI/CD stuff, but there are our friends in Yandex. I think they built Allure, which is a screenshot down there. So you see up here, you've got your test, and you got your test body and all the steps. If they're passing or failing, they go green or red, and you can build in your CI/CD pipeline, and you can have nightly builds, for example. So yeah, in the end, what the ideal flow is, you've got your product people writing you the specs, the QA team writes all the BDD tests, developers automate or dedicated QA team automates the steps. You build some steps and then you can extend them. And these tests can be integrated very, very easily with ticketing systems like Jira. So you can have your acceptance criteria in the ticket, you can develop the code, you can run the tests, you satisfy the tests, they are back reported into the ticketing system, and then you ship the code and it's all job done. It's very easy once you achieve a level of maturity and complete your testing library. And with this one, I think that's it. We're out of time anyway, so thank you all very much. I'll be happy to answer any of your questions. Any questions? Yeah.
Shout?
Yeah, just shout. I'll repeat that for you.
Okay. Well, it wasn't a question, it was an observation.
Yeah.
That if you reach a level of maturity with BDD, then another benefit that you didn't list is that the BDD approach decouples your testing from your implementation. So if you focus on achieving test coverage through doing BDD, you don't have to write unit tests for your classes because unit tests are coupled to your implementation. So if you have a large suite of unit tests that is providing test coverage, the cost of change is higher because when you refactor your code, you then have to refactor your tests. Whereas if you're doing BDD and you focus more on behavioral tests, if you refactor your code, the test doesn't have to change and it's much quicker. You achieve a much lower cost of change in your system.
Exactly. So yes, I completely agree. And I can also see your Java background because you said classes and all that stuff. If you do use Go, for example, that things are a bit different. A bit easier to refactor and you don't get all this much complexity. But yeah, I can totally agree. Yeah. Okay. So any other questions? Yeah. How do you manage your test data? With scenarios, with scenario outlines. Let me show you an example actually here. Just 1 minute. Yeah. Yeah. Okay. You can see an example here, yeah? So 5 minutes here is actually a parameter. It's regular expressions. And once you build the test, it's a regular expression. It's an integer number. And it's getting parsed in the step implementation. And that's probably going to be another parameter here in the test. It's automatically getting injected by the framework most of the times.
Can you list some cases that BDD is not good to approach for? Let's say for example, something like low level, if something is like persisted, or if the parser works and we have like a big kind of custom thing that we're parsing, like which cases BDD is not a good fit for our tests?
It's not very easy to test if you don't have predictable output in your code. And you can think of it, it's like if you give a human a test and it's very difficult for him to test it, then it's probably difficult for the BDD test. And it's also difficult for the unit test as well, because you have to mock so many things and you don't get predictable output. I think in my experience, there's no bad approach in testing. It's the way the code is written. If you write code that's easy to test, then all the tests can be written easily in a test. If you've got code that is tightly coupled with external systems, of course, unit tests are difficult. And then it's about the code architecture and how you approach some coding practices in order to write testable code and testable solutions. So then it comes back to the requirements. Do I want to write something that it's very difficult to test, or do I want to write something that is easy to test? Cool. Any other question? We've got two more. Yeah.
Hello. Thank you for the nice presentation. So, did you use this testing approach from the start of development?
No.
Okay, so you adapted somewhere down the road, right?
Exactly, yes.
Okay, so how did you build the vocabulary, the needed vocabulary to build the scenarios?
Yeah.
And how do you keep it updated?
It's a gradual approach. We started with a project that it was a niche inside the whole company. We don't use it for all software, for all services that we have, definitely. But we took a risk-based approach, and we started from the easiest one. The software that was easy to test, it had predictable output, and it was very difficult and labor to work your way up with a QA engineer, and it was difficult to test all the interactions. And it was very repetitive. So that's where we started. We want, of course, to extend it and see how it goes from there. In the past, I have seen people exercising browsers with Selenium and other drivers, and that's very successful. But then things become a bit more complicated. But you keep all the complication for the technical team and the technical challenges for the technical team to solve, rather than the business people and the QAs that don't have that much coding experience. Cool. And I think we have another one.
Hello. How do you test your integration with the third parties? For example, do you use behavior-driven test?
With the third parties, that's a good question. I don't know, because it's not in my team, so I don't know. Of course, if you mean about, for example, Google login or stuff like that, yeah. Or integrations, because on IFOD we have integrations with vendors and then partners and...
No, actually, I mean integrations with third parties that you need their feedback, their data to continue your flow. For example, it may be, let's not say a database, because you can mock your database, but another system in your environment that is useful for you.
Here we focus on the end-to-end side of things. We don't think about unit testing. So if you want to test this one, for example, a user places an order on eFood, you have eFood up and running in a test environment, and then you run your tests against that environment.
Okay. Are you having microservices, or it is a monolith?
We are actually doing microservices.
Okay. So it's a microservice. How you test each other, their communication?
You don't care about this, because I'm going back, and you test about the output. You don't care how the microservices play with each other. We are, for example, we care that the browser shows the order. We don't care if we have like 10 microservices in order to digest an order. We focus on what we provide to the user here. Okay. Any other one? No? If no, enjoy the rest of the conference, and thank you very much.